This guide is meant to help you get quickly up and running with the deployed REST API you can use as a starting point for applications you're developing. We won't be going deep into the details behind why we are doing what we are doing. This tutorial will quickly get you up and running with a serverless API as fast as possible, and you can then decide where you want to go next. If you want to follow along as we do things, the code for the final service is available in GitHub for you to copy and paste. The URL is below in the video description. The first thing we need to accomplish is to have somewhere to deploy to. Serverless development relies on cloud vendors to help get your applications onto the web as fast as possible, and the most widely used vendor for this is AWS. If you already have a verified AWS account you can use, then you're all set. Otherwise, you will need to go to aws.amazon.com/console and click the Create AWS Account button. At that point, just follow the instructions for creating your account. Don't forget to go through the verification process in order to deploy your serverless services. Installing the serverless framework is, thankfully, very easy. Since it is an NPM module, it requires Node and NPM to be installed. In case you do not have it installed, you can find details on how to do so for your preferred platform at nodejs.org and clicking Downloads. With Node and NPM installed, it is recommended to install Serverless Framework as a global module. This can be done with npm install-g serverless. With prerequisites out of the way, let's use a feature of the Serverless Framework to help get us bootstrapped as fast as possible. Just run the command serverless, and we are then given some options. These are templates for us to choose from. For this guide, we are going to select the AWS Node.js HTTP API. Feel free to name it whatever you want, but I'm just going to keep the default here to keep it simple for now. After choosing the name, the framework creates a folder with the same name and also pulls down the code for the template we chose. Now it's asking us if we want to log in or register an account for the serverless dashboard. Let's choose Y so we can do that. Serverless Dashboard is a tool provided by the Serverless Framework to help make managing connections to AWS easier, manage configuration data for your services, monitoring capabilities, and the ability to read logs for your Lambda functions, amongst many other features. The dashboard is free for single developer use, and we will be using it for the purpose of this getting started, because the dashboard makes it so much easier to manage connections to our AWS account for the deployment we will be doing shortly. You should be on the login page, so click Register and create an account using GitHub, Google, or email address and password as you wish. Give a username, and you are all done. The CLI should now reflect that an account has been created for you. Now we want to create our connection to AWS, so let's choose the AWS Access Role option, and this will open another browser window. We want to add a simple provider, and by clicking the Connect AWS Provider, this will open our AWS account to a quick Create Stack page. There isn't much to do here except confirm the selection at the bottom and click Create Stack. Now we just wait a few seconds, refreshing every now and then until the stack is created. Switching back to our providers page, it will automatically detect when the provider is created. And that's it. The CLI has also now detected that our provider has been created and is asking us if we want to deploy. Let's just say yes and wait a few minutes while our first deployment completes. Every API needs a way to receive data to create new entities. In our example, let's create a customer API that creates new customers and allows retrieval of customer data. To store user data, we will need a database, and for our purposes, we will use a database service called DynamoDB, because it has features that work really well in a serverless environment, including being quick to deploy and use. We are going to open our serverless.yaml, and at the end of the file, add some additional configuration. We will also need access to the name of the table we are creating in our code, and the easiest way to do this is as environment variables. So let's add another couple of lines to make sure that's available as well. While we are here, let's wrap up the extra bits we need. We insert this block to give AWS Lambda permission to access our DynamoDB table so we can actually store and read data from it. And lastly, add our new endpoint. This is where we define that we are adding a new function with the name createCustomer. We point out where the code is stored in this handler parameter, as well as at least the minimum configuration for the HTTP routing, such as the path and method accepted. Time to add some code. In our folder, we add a file called createCustomer.js, and within that, we add some code. Put simply, this code reads data from the event object passed to it. We extract the body of the HTTP request, and then use the AWS SDK to put the object into our DynamoDB table. Here is where we read that environment variable we configured with our table name. And you may have also noticed we are using an NPM module, the AWS SDK module. Let's not forget to install that using npm. So let's do that with npm install --save aws-sdk. And with all the pieces put together, let's deploy. Just type serverless deploy. With the deployment completed, the framework gives us a summary of our endpoints. Now you can test this whichever way you prefer, but I'm going to use a basic curl command to send a test request to our newly minted endpoint. And just like that, it looks like it worked. But what happens if we had an error? Inducing an error should be relatively easy since we don't have validation added to our post body. Something you probably want to make sure to have done before going into production though. But what this means for us is that we can send another curl request but have a malformed JSON string. And there we go, internal server error. This is where the dashboard can really help us. By clicking through to our deployed service, immediately we can see that the dashboard has captured our first request as well as the second one that errored out. Why did it error? Just click through to the errors. Then let's look into the log itself. And here we can confirm the reason the error occurred was because the JSON document was invalid. The dashboard can make a great debugging and troubleshooting tool while we build our services, but also once in production. And we need to keep an eye on things, especially when we have customers using our services. We added a database, we sent data to it and stored the data. Let's close this off by adding the ability to retrieve that data. In our serverless.yaml, we want to add a new endpoint to make requests on. So in the functions section of our configuration file, we add a new function called getCustomers with a handler called getCustomers.getCustomers. Our path is just to root since we want to retrieve all customers. The method is also a GET request. Small bit of cleanup, we don't need the default handler configuration created with the initial template, and we can delete this default handler.js file as well. But let's also add our new file called customers.js, and in that file we will drop some code. The only thing to note here is that we use the scan command on our DynamoDB table to retrieve all the data. With the code in place and the HTTP event configured, we run serverless deploy. And once completed, let's use curl one last time to retrieve the data we put in not so long ago. As you can see, to get up and running with some basics is fast and reliable. Not only have you gotten a couple of endpoints for an API up and running, they are, at this stage, production ready as far as infrastructure is concerned. There is full redundancy and load balancing. You could send real traffic to these endpoints already, and it would manage under the load. Oh, and if you ever wanted to remove the service and all the parts of it, Serverless Remove accomplishes exactly that. Feel free to drop a comment with any questions you may have and like the video if you found it useful. Thanks and bye for now.